What's poppin' bimchos? Today we're going to be looking at JavaScript numbers. You'll need to put your big boy pants on, as there will be many things here that are just strange. First up, JavaScript treats numbers slightly differently than most programming languages. In lower level programming languages, you must specify the type of a number, such as a float or a double. JavaScript don't got no time for that shiz. So instead, it just treats all numbers as 64-bit double precision floating point numbers. Big words. What this means is that you can write numbers with decimals or with no decimals, or even scientific notation without specifying the type, and yet I struggle to figure out which way the USB is plugged in. Now briefly, let's go over the nerdy stuff. As mentioned, JavaScript stores numbers as a 64-bit number, so that's broken down into three parts. A value. This is 52 bits long, so that's bit 0 up to 51. Remember, in JavaScript, we start at 0 and we go from there. 2. The exponent. This is 11 bits long. Those are bits 52 to 56. 3. And lastly, the sign. This is a 1-bit and it's bit number 63, for a total of 64 bits. The sign is essentially just saying whether it's a positive or a negative number. And again, just a reminder, we start from 0 in JavaScript, not 1. In the next session, we are going to be looking at integers. Quick fast, integers or whole numbers are accurate up to 15 digits. So if we say let num correct equal that, I'm pretty sure is 15 nines, and if we say console.log num correct, we get 15 nines. Don't worry, I checked it. Totes. Next up, if we use something, let's say let num sure equal 16 nines, you get a bit of a different result. We get, that doesn't quite look right. Yeah, okay, cool. The above happens because at 15 nines we reach the max number JavaScript can handle, and thus can no longer figure out that number. Now we will look at floating points. Floating points are essentially decimal numbers, 2 decimals, 5 decimals, however you want it. Now for the most part, computers are really good at this stuff. However, in some languages, not so good at this stuff. If you have ever felt bad at math, start using floating point numbers, you will immediately feel like a genius. Here is a simple example. With our floating points, let's say that num quick maths equals 0.2 plus 0.1. Now you'd expect that to be 0.3, however, you'll see we get 0.3000000, a whole bunch of zeros, and 4. Yeah, I thought at some point Skynet was supposed to be taking over, instead we get this. I don't think we have all that much to worry about. Anyway, not to fear, there is an easy way to get around this with some quick maths. So if we say let num a equal 0.2 and let num b equal 0.1, we can essentially just say that quick maths to maths is going to equal num a times 10 plus num b times 10, and then divide that by 10. By taking your decimal number and multiplying it by 10, you are moving that decimal position over by 1 step, which then means that weird little rounding goblin doesn't come up again. If you haven't been paying attention up until now, this would be the part where I would suggest you do so, as it will save some headaches much later on. First and foremost, in JavaScript, the plus operator is both addition as well as concatenation, like having your use key and shoot button be bound to the same button. Sure, why not? Anyhow, this section is going over some weird number business. First up, we know that if we have a variable called numWeirdA, which is 10, and another called numWeirdB, which is equal to 90, when we print that out, we will get, correct, 100. Two numbers added together equals a number. That makes sense? No weird surprises there. Now the same thing, but we change the numbers to strings, and 10 plus 90 goes from 100 to 1090. Okay, it's a little bit odd, but this makes sense, as it's still a string. Rad. So what if we take a number and a string? So let's remove the quotes from 10 and hit save. Oh, that's still the same. Okay, what if we reverse it and take a string plus a number? So we will undo 10, make it a string, plus 90, hit save, and still the same thing, 1090. Okay, so this all makes sense. A number plus a string is always a string. This is good. Now let's just do one more example to make sure we understand this. Now we will add one variable called numWeirdC. NumWeirdA is going to be the number 10, numWeirdB is going to be 90, and numWeirdC is going to be 20, but it's a string. Okay, so with everything that we've learned so far, what do you think the output's going to be? That is correct, it is 10020. You may have expected that to be 109020, because it goes 109020. However, JavaScript interprets from left to right, so technically numWeirdA plus numWeirdB is just a normal sum. Then once that's done, it will concatenate with numWeirdC, which is 20, to get 120. Okay, wild. Ooh, it is what it is. Now, there is some more caveats to that. JavaScript can still do math operations on strings as long as it isn't addition. Division? Sure, why not? Multiplication? Absolutely. What about modulo? Yep, that still works. Addition? What even the hell is that, my guy? Anyway, now we move on to nan. Now, what exactly is nan? Nan is something you will see very often, unless you've watched this video and you've become a number ninja. Any number that is used in some way that JavaScript can't figure out will return nan, which stands for not a number, to let you know that something has gone horribly wrong. So, let's use an example. If I try to say console.log 50 divided by cheeseburger, we get, you guessed it, nan. You can, however, also use a function called isNan that will return a true if something is not a number. This is useful to figure out if you have made a boo-boo somewhere. Another thing about nan, don't use it. If you use a nan value in a mathematical operation, it will always be nan. So in this example, we have num not nan equals 5 and num nan equals nan. If we now save this, now you will notice, oh, we've got nan again. Or if you do something crazy like changing the number to a string, you will now get 5 nan. Next we're going to look at infinity. Yes, it's a thing. In JavaScript, infinity and negative infinity are returned once you return a number that is larger than JavaScript can handle. A simple example is the following. If we say 1 divided by 0, it will return infinity. Or taking a number and multiplying it by 2, it will eventually reach infinity. Not much to go over here, but generally if you see this, either you made a mistake or someone else has. Next we'll be looking at hexadecimal. JavaScript can deal with hex values as well. By default, JavaScript displays numbers as base 10. The number system that you are hopefully already familiar with, 0 to 9. However, you can return numbers in different base systems. First off, if you prefix a number with 0x, JavaScript will read it as hexadecimal. So 0xAA will be 170 in base 10. Cool, but can you do it with more bases, like base 2 or binary? So for 255, it will be, that's correct, 8 ones. Those chaps learning subnetting in networks, you're welcome. So in JavaScript, we have this function called toString. This will take whatever number you give it and convert it to that particular base. So in this case, we have base 2, which is binary. So if we change this number to, let's say, 100, you will now see we get 1100100, which is 8 bits and is 100. You can also do stuff like base 16, which will give you hexadecimal. Or you can even go so far as to put it in base 36. And that concludes today's video. As always, if you wish to learn about any specific topic or programming language, feel free to leave a comment down below. And congratulations, you have leveled up in programming. Hope to see you in the next video.